This is IBM Museum. On this short video, which is ahead of me working on a couple PS2 Model 30 286 units to get them operational, fully functional again, I want to go over and show just an overview of the different planars that you can find on these systems, and also a factor that you have to consider when you do the modification of the Dallas real-time clock chip module that, of course, is going to be the primary aspect to getting the system functional again. So I'm going to get off camera, get turned around, and start pointing things out. So for someone seated in front of an operational unit, this would be the orientation of their left-hand side of the case. This is where the adapters, of course, are put in horizontally on the system. I'm going to go through and actually remove the riser support and riser for a little bit better view into the system. Now, the planars that were used in the Model 30 286 were also used in the Model 25 286 as well. That's the all-in-one unit that has the integrated screen. On the PS2 Model 30 286, they have this cable connection here to where they route to a plug for the monitor being connected up to the back that's above the planar. On the Model 25 286, of course, that has internal circuit wiring that's connected to that header instead, as we've seen in the previous videos on the Model 25 units that I had opened. This is the Type 1 planar. All that means is that's the planar that was in the systems, the PS2 Model 30 286 and Model 25 286 when they were first released. The easy way to tell this planar, or the distinguishing feature, is a single EEPROM, 40-pin EEPROM chip that's in this location. And the video RAM is soldered on the planar in this area here. Now, the 286 CPU would normally be below this Kingston module and in this location here, very close to where the Dallas chip is. And then the 287 numeric coprocessor is actually partially obscured in this below the Kingston module here. And of course, if you have the Kingston module in place, you wouldn't have the 287 chip installed. You would have a 387SX or 387SL numeric coprocessor installed in this position on the Kingston module itself. Since that does go through and it adds the CPU here, you're upgrading to a 386SX. And this Kingston module here is actually the 33 megahertz model. So this is a very good upgrade for these units. It's the fastest Kingston module that could actually go on these units. Now, it'll be very much more visible with the orientation of the 286 CPU in the socket. The Kingston module is in this position on the Type 1 planar, with the Type 2 planar, which I have here, and I have the same type of module in place on this unit, also the 33 megahertz unit. But as you can see, it's a slightly different orientation, even though it's the same board. And that's also because on the Type 2 planar, the orientation of that CPU and socket was changed slightly between the Type 1 and Type 2, even though other components in that area did not change. The socket for the 287 numeric coprocessor is not obscured by that module being seated in the 286 socket in this case. Now, the primary distinguishing features of the Type 2 are these two separate BIOS EEPROM chips that do the same function as that 40-pin chip does on the Type 1. And the video RAM is actually on these little boards. They're then soldered into the planar. So they're above the planar on their little boards. But otherwise, the layout between the Type 1 and Type 2 don't change. It doesn't change much otherwise. With the Type 2 and especially the Kingston module rotated around and sitting up higher than what the 286 CPU would normally do, it's very evident that there's a very tight clearance in here on the side of the Dallas module. And that's the side where you'd actually grind away to access those internal battery leads on the chip to be able to disconnect the internal battery and have the wires for an external battery. So with this, it would take a battery holder that would be off in a different position that couldn't necessarily sit over the top and block the ability to maybe pull out that Kingston module unless you actually brought out the disconnected the Dallas module as well. So it's just a consideration when going through and putting the battery holder around that, or just something to be aware of how that clearance is between the side of an upgrade board like the Kingston module and that real-time clock chip. So I'll go through and I'm going to modify some of the Dallas chips, and I'll come up with an area that I'll put that battery holder. I'll go through and feature both of those as I go through, and I'll also show the performance of how these Kingston modules really improve the functionality of the system in later videos. But I wanted that short video just to go through and to show the planar layouts that you'll encounter out there with these systems. I don't really know the reason why IBM had that distinction and came out with the Type 2 planar for these units, because they did duplicate the BIOS versions between each separate type of planar, and for the lifespan of the system, the IBM technician would encounter both styles of planar. It's just one of those, things that's helpful to know about the unit. So let me get back on screen here and close this video. If you did like this video, click on that like button. Please subscribe to my channel. There'll be much more content as we go through, including the content on these systems as I work with both styles of the planars that you can find in the Model 3026, Model 2526 to get those systems going. But that's all I have for now. This is IBM Museum. Thank you.